Hello, welcome to Algebra Lesson 11.6 combined with 5.2. It's a section we skipped because it goes well with this. This is a section on variation. Last year we may or may not have spent one day on variation. Sometimes we do, sometimes we don't in pre-algebra. But it's a relationship between values. And what we see right here is definitely a relationship. It's definitely a function. And what kind is it? I hope you know it's a linear function, right? Because it's just a line with a slope of 5. And it goes through the origin. So if you just stick in x values, 5 times 0, 5 times 1, 5 times 2, you get these 3 points, right? So if I graph those, I get something like that. This is actually also representative of direct variation. Inverse variation is not an equation like that. It's more of an equation like this, where it's not y equals 5 times x, but 5 divided by x. Now, an easier way to work with that sometimes, and this is the main equation, when you have an equation of variation, of inverse variation, it usually looks like that. And you can see why it comes in this chapter. It's like a rational expression or equation. But if you were to multiply by x to clear the fractions, you'd end up with x times y is 5. So let's take a look at some points. Now for this, you can't just put in 3 points and expect to know how it's going, how it's moving. So let's check it out. First of all, you can't put in 0 because it would be an extraneous value, right? It's not allowed. It's not part of the domain. But 1 would work. 5 divided by 1, 5 divided by 2, 5 divided by 3, 5 divided by 4. Okay, so I see what's happening here. 5 divided by 5 is 1. So are those getting larger or smaller? They're getting smaller, right? So what was happening between 0 and 1? Because there's got to be something going on here, right? So if I did, if I put in a half, 5 divided by a half is 5 times 2, that's 10, right? 5 divided by a third would be 5 times 3 or 15. 5 divided by 1/4 would be 20. So notice from 0 and then a fourth, a third, you're going to come drastically down. And then you're going to kind of even off. But what do you think you get values on the negative side? What would happen then? How are they different? Not very much, right? With the exception of the signs. Aside from the signs, these are all still going to be the same values. If you put in a -1, a -2, a -3, a -4, etc., or if you put in those negative fractions, you're also going to get the same numbers but opposites. There's one other we should probably, whoops. Oh, wait a minute. Oh, here's the values, sorry. Oh, I don't know why that 5 blinks, but anyway, the equation would be graphed like so. Thanks to Desmos, there it is. It would have arrows on the ends, but we're not going to fret that right now. Notice it is very definitely not a straight line. It is a curve, and it's asymptotic to both axes. And it kind of forms a hyperbola, more about that in Algebra 2. We're going to mostly focus on just the values here, though, because we're going to look at data values that are usually positive. So remember when we did other, like scatter plots and stuff, we looked at quadrant 1 only. It's kind of what we're going to do going ahead now. I'm not sure if I actually gave you a little sheet with notes on it or not. So I thought I'm just going to put the notes up here because this does go through what we've got. So as you write the notes, we're looking at variation, and it is 11.6 and 5.2 if you'd like to write that down. 11.6 is the inverse, 5.2 is the direct. So direct variation, the wording, the order of the words is very important. Y varies directly with x if y equals k times x. In other words, y varies directly with x if I can find the y value by multiplying x by some constant k. And k has to be a positive constant, and the graph would be a line with a positive slope. Now, when you have that situation, when you have a line with a positive slope, both variables increase at a constant rate, and that rate is the slope, right? So it's going to look, something like that. It might not be as rapidly increasing, but y will vary directly with x if you have a line with a positive slope. Now, if you happen to have a line with a negative slope, it doesn't mean it's a bad line, it's just not direct variation. Also, there are other types of variation besides direct and inverse that we're just not considering at this time. You may, if you have a statistics course or if you keep going in math, you'll probably run into some of them, but not right now. Inverse variation is the one that ties in with this chapter. And y varies inversely with x if y equals k divided by x. So to find y, you could take the constant, divide by x. Now that's kind of hard to work with, right? It is the main equation for inverse variation. That's the main form you use. But, and this is, by the way, the hole in my notebook paper, in case you're wondering what that bizarre spot is. If you, like in the warm-up, if you multiply, then you get x times y is k. And for inverse variation, k is also a positive constant, and this time the graph is a curve. Now, as one variable increases, again in quadrant 1, as one variable, as we go left to right, in other words, increases, the other decreases, but not at a constant rate. So it does not have a slope, but it does have a curve. And it does, the shape of the curve depends on what this value for k is. So k is called the constant of variation. These equations that are in the boxes, especially the two on the outer edges, are very important. Actually, all three of them are, because that's what we're going to look at to see if some data values are representative of direct variation, inverse variation, or neither one. So let's take a look at a few examples. And we're going to have some sets of data values, xy points as it were. So what we want to first do is check to see if y varies directly with x, and if it does, what is the value of k? So in other words, if it does fit this equation, y equals k times x. In other words, do I take the x's, multiply it by a certain number to get the y's? Well, what do you think? 1 times 1, 2 times 1, 3 times 1, 4 times 1, 5 times. It seems that you do, and k is 1, right? So that would be a yes, and oops, sorry. So that would be a yes, and k is 1. I thought I had those on there. I don't, apparently. How about the next one? 1 times 2, 2 times 2, 3 times 2, 4 times 2, 5 times 2. Yeah, so I always multiply by 2. So the constant of variation, k, is 2 here, right? So these are both yes. K was 1, k was 2. How about this guy? 1 times 2, 2 times 2, 3 times... That is not times 2. Wait a minute. So is this direct variation or not? It's not, right? So this is a no. Nope. Nope. How about the last one? 1 times negative 2, 2 times 2, 3 times negative 2. So this is not either, right? What if these were all negatives? Would it be direct variation? It kind of seems like it, right? Because it'd be times negative 2 times negative 2 times negative 2. But somebody out there is going, no, it can't be. It's definitely not. Why not? Because k is defined to be a positive constant, right? It might be a nice function, but it is not showing direct variation. Okay, let's look at some for inverse variation. Does y vary inversely with x? If so, find the value of k. So let's try them. How on earth am I supposed to do that? Well, use the other form of the equation, right? The other form of the equation says that x times y equals k. So really, all you have to do is check the product of the x and the y. If they're always the same value k, that looks really weird. It was supposed to be a cursive k. Oh well, humor me. Or ignore it. Either way, we just want to multiply these and see if we get the same thing each time. So I do 1 times 12, I get 12. 2 times 10 does not equal 12. So we're done already, right? That is not. How about the next one? 1 times 120, 120. 2 times 60, 120. 3 times 40, 120. 4 times 30, 120. I bet this is. Is it though? Check it. 5 times 20 is 100. 5 times 4 is 20. Yes, so this one is, right? So this one is a yes, but what is k? K is the thing you get when you multiply, right? So k equals 120. How about the next one? You can see why I didn't write these. I'm actually not even using the mouse pen. I'm just using the mouse, the little, wow, forgot what it's called, that little rectangle that I use for my mouse. Anyway, that one was yes. How about this one? 1 times 2, 2. 2 times 1, 2. 3 times 2/3, shortcut. 4 times a half, 2. 5 times 2/5, 2. You seem to be saying 2 a lot, right? That means it's a yes, and k is 2, right? Because that's what they multiply to be equal to. K equals 2. Okay, how about the last one? I'm not sure why I didn't write them here. Yes, I am sure. It's because it's kind of a pain. Okay, the last one. 1 times 20, 20. 2 times 10, 20. 3 times 15. I'm sorry, 3 times 5, 15. That's not 20. So that one's a no. Okay? K is called the constant of variation. So the constant of variation on these guys was 1, right? Because you just multiplied by 1, so k is 1, and the constant of variation then is 1. On this guy, you multiplied by 2 every time, so k, the constant of variation, equals 2. For the ones on the bottom, the constant of variation would be 120, and again 2. All right. One more thing we need to do with variation. And your assignment is on a worksheet, and it's split down the middle. So the left side is all direct variation, front and back. The right side is inverse variation, front and back. Okay, so next. From a pair of values whose relationship of variation is known, we can find an equation of variation. Why? Well, so that we could figure out some other values within applications of sorts. So you'll have some with, like steak and riverboats and things like that on the assignment, and that'll work with this. Okay, so anyway, remember the equations. So for direct variation, if we know the relationship is direct variation, that means that y equals k times x. That means that 28 is k times 7. That means that k is 4. And that means, R2D2, I'll catch her in a minute. And that means that y equals 4 times x. Next one. If y varies directly as x, and y is 30 when x is 6, that means that 30 equals k times 6. That means that k is 5, because 6 times 5 is 30, right? And that means the equation of variation would be y equals 5x. Not terribly hard, right? That it looks like it's hard, but then you put them in there and it's like, oh, is that really all we're doing? Yep, it is. So then the next one. Y is 30 when x is 8. That means 30 equals k times 8. This one's not as pretty. You get a fraction, right? 30 over 8 is 15 over 4, or 3.75 if you wish. So then what's the equation of variation? Y equals, pick which one you want, times x. Okay, let's look at the inverse. For inverse variation, you can try to use the first equation, but I would use the second one. And then at the final answer, put it into the first. So if y varies inversely as x, that means x times y equals k. So that means that 3 times 25 is k, which means k is 75. Put it into the other equation, and y equals 75 over x. I know, it doesn't look nice. The preferred format is over, but, Microsoft Office. So anyway, next one. Y is 8 when x is 10. That means k has to be 10 times 8, which is 80, which means that y equals 80 over x. Again, please use over. Then the last one. 0.6 times 0.4 is k. That means that k is 0.24. And that means that y equals 0.24 over, please use over, x. And that's it. So just make sure you remember the wording on these things, especially when you get to the ones that have the word problems, because we want to remember that y varies directly as x. So if the number of pounds varies directly with whatever, make sure that the first thing that varies directly as is in place of the y. So watch your wording, and then you can figure out which one is which variable. So do well. Have a good rest of your day.